Have you ever wondered how mathematics can shape our world, particularly in the realm of transportation? Enter the McGinty Equation. This intriguing piece of mathematics, also known as the MEQ, offers a unique perspective on transportation systems and their optimization. The equation itself is a marvel of mathematical ingenuity, combining elements of quantum field theory with fractal geometry, and even considerations of gravity. The McGinty Equation looks complex, and well, it is. But don't let that deter you. At its heart, it's a tool designed to help us understand and model the world around us in more accurate and efficient ways. And when it comes to transportation, that means creating systems that are not just effective, but also sustainable and forward-thinking. Imagine a transportation system that seamlessly blends cutting-edge vehicle design, infrastructure, and mathematical brilliance. That's the potential of the McGinty Equation. Ready to delve into the mechanics of this fascinating equation? Buckle up. The McGinty Equation may seem complex, but it's quite straightforward when you break it down. Let's start with the first component, PESQFT. This is the solution of free quantum field theory. In plain English, imagine a field like a football field, but this one is full of energy and particles that are constantly interacting and changing. This part of the equation is all about predicting how these particles will behave. Next, we have the fractal. This represents the fractal potential term. Fractal might sound like a piece of science fiction, but it's just a pattern that repeats itself at different scales. You see fractals in nature all the time, like in the spirals of a pine cone or the branches of a tree. In the context of our equation, this fractal term helps us account for the repetitive patterns seen in the quantum field. Lastly, we have gravity, G. This signifies the effects of gravity on the quantum field. We all know gravity is the force that keeps us grounded on Earth. But in the quantum world, gravity is a bit of a wild card. It can have profound effects on how particles behave. This term in the equation allows us to account for those effects. Each term of the McGinty Equation, PESQFT, piece fractal XTDMQS, and piece gravity XTG, plays a crucial role in understanding the complex dynamics of the quantum field. They allow us to predict and model the behavior of particles in this field with incredible accuracy. But why should you care about this equation? Well, understanding these components not only gives us insight into the fundamental workings of the universe, but also opens up exciting possibilities for practical applications. One such application is in the realm of transportation. With a basic understanding of these components, we can start to see how this equation could revolutionize transportation. Now that we have a grasp on the McGinty Equation, let's explore how it can be applied to transportation. The McGinty Equation, with its intricate blend of quantum field theory and fractal geometry, may seem more at home in a high-tech physics lab than on the bustling streets and highways of our cities. Yet, the principles underlying this mathematical marvel can indeed be applied to create efficient and sustainable transportation systems. Let's start with vehicle design. The McGinty Equation's fractal component, symbolized by fractal, suggests the concept of self-similarity. In transportation, this could translate to modular vehicle designs that are scalable, yet retain their efficiency regardless of size. Think cars, buses, or trains that can be easily modified or expanded while maintaining optimal performance. Next, we turn to infrastructure. The quantum field theory component of the equation, represented by PESQFT, could inspire a new way of planning and building our transportation networks. Just as particles in quantum theory can exist in multiple places at once, our infrastructure could be designed to offer multiple routes and modes of transport, enhancing its flexibility and resilience. Sustainability is another critical area where the McGinty Equation could make a significant impact. The equation's gravity component, denoted by PESGravity, underlines the importance of considering the physical forces at play in transportation. By taking into account the gravitational pull, we can design transport systems that minimize energy consumption and reduce carbon footprints. Finally, the McGinty Equation's inherent adaptability, underscored by its ability to incorporate different variables, mirrors the need for our transportation systems to be adaptable. As our cities grow and change, so too must our modes of transport, always evolving to meet the needs of the hour. Imagine a world where transportation is ultra-efficient and sustainable, all thanks to the McGinty Equation. In this world, journeys are smoother, quicker, and lighter on the planet. It's not just a dream, but a possibility within our reach if we dare to embrace the wisdom encoded in this fascinating equation. We've covered a lot today, so let's summarize the key points. Firstly, we explored the intrigue of the McGinty Equation. This equation, often represented as piece xt equals sign piece qft xt plus piece fractal xt dmqs, is a solution of the free quantum field theory and mechanical systems. It's like a mathematical fingerprint, a unique identifier that helps us understand the universe in its own language. Then, we dove into the components of the McGinty Equation. We learned about the modified version of the equation, where gravity, xtg, represents the perturbative effects of gravity on the quantum field, and g is a parameter that characterizes the strength of the gravitational force. We also learned about the fractal potential term Vyt, that has a self-similar fractal structure, described by the constant parameters V0, L, and S. In the third part, we discussed how the McGinty Equation applies to transportation. Imagine a transportation system that's as intricate, efficient, and sustainable as the universe itself. That's the potential of the McGinty Equation. It's not just about understanding the universe, but using that understanding to create practical solutions for our world. Lastly, we pondered the potential for a more efficient and sustainable future. The McGinty Equation offers a blueprint for such a future. By applying the equation to transportation, we could potentially design vehicles and infrastructure that are ultra-efficient and sustainable. But remember, the McGinty Equation isn't just about formulas and calculations. It's about a vision of the future. A future where transportation is not just a means to an end, but a harmonious part of our existence. A future where we don't just travel, but travel in a way that respects and cherishes our planet. So next time you think about transportation, remember the McGinty Equation. It's more than just numbers, it's a vision of the future.